Hi, good day, grade 10 learners. Our topic is about the volume pressure relationship that is commonly known as the Boyle's law. What is Boyle's law? So here is a fact about this topic, Boyle's law. The relationship between the volume and pressure of gases at constant temperature was first stated by Robert Boyle during the 16th century. He performed an experiment wherein he trapped a fixed amount of air in the J tube. He changed the pressure and controlled the temperature, and then he observed its effect to the volume of the air inside the J tube. He found out that as the pressure is increased, the volume decreases. He finally concluded that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. So that is a fact about Boyle's law that was established or proposed by Robert Boyle, one of the known scientists. So, mathematically, here is the equation for Boyle's law. I will show you in a bond paper. So here it is. Baliktad. Or, mathematically, here is the equation of Boyle's law. V1 P1 equals to V2 P2. So, in solving this equation, in solving problems involving Boyle's law, it is very important for us to know the given and the quantity that is required for us to be able to solve the problem. So, I will teach you some techniques in formula derivation regarding this formula, Boyle's law. Baliktad po siya. It is because as the pressure of a gas inside a container increases, the volume of the gas inside decreases. That is why Boyle's law is states that the volume and pressure of a gas inside a container is inversely proportional to each other. So they are inversely proportional to each other. Meaning to say, when the volume increases, the pressure decreases. So as we squeeze the balloon, the gases inside are being pushed. We are applying pressure actually. The gas molecules are being pushed to each other, so they are becoming closer to each other, and therefore their volume decreases. So this is the mathematical equation of Boyle's law. V1 P1 equals V2 P2. Now, I'm gonna teach you the formula derivation technique when solving, for example, V1 given P1, V2, and P2. So here is what you're going to do. For example, you are going to solve for V1. So all that you have to do is to transfer this P1 down. Okay, making it V1 equals V2 P2 over P1. So that is now our formula for volume. Volume 1 is equal to volume 2 multiplied by the pressure 2 over pressure 1. Okay, another one. For example, we are required to find or to solve for volume 2. So in that case, all that we have to do is to transfer this P sub 2 down here, giving us the formula V2 equals V1 P1 over P2. So that is another one. Third, formula derivation. Example, we are required to find for P2. So if we are required to find for P2, all that we have to do is to transfer V2, V sub 2 down here. That will become our denominator, giving us V1 P1 all over V2 will give us P2. So that is our third formula derivation for the concept of Boyle's law, or for problems involving Boyle's law. So we have the fourth and maybe the last formula that we have to derive out of this Boyle's law concept is when we are asked to solve for P1, or is it P1 or V1? Okay, P1. Say for example, we are required to find for P1. So V1 P1 equals V2 P2. So again, all that we need is simply to transfer V1 to the other side of the equation, making it as our denominator. After we have transferred V1 to the other side of the equation, it will become our denominator. So the formula for pressure 1 will be this one. P1 equals to V2 P2 over V1. Okay, so there you have it. We already have 4 formula derivations for the concept of Boyle's law that we need in order for us to be able to solve for the problems involving volume pressure relationship. All that we have to do is to make sure that all units are the same, so we will be able to get the correct result. So formula number 1, we have formula number 2, we have formula number 3, and last we have formula number 4 for Boyle's law. So up next, we'll have Charles' law. Thank you.